Okay, hello everybody. Our statistics course, and we yeah want to move today to the next topic. What did we do the last time? We ended our topic about inequality metrics, and in the end, I just showed you some data on the national income distribution internationally and especially for Germany. And there, at one point, we saw in the international comparison that in general, Germany would be one of the countries which has quite equal distribution of incomes compared to especially the UK and of course also not UK, this is Italy, this is UK and the United States, but that we have to be careful if we look at these data, because we have to know which data counts for this measure. And if we take these time series here, then it is the data which we got from the official institutions. And this is one main task which you have if you are doing quantitative analysis, that you look at the quality of your data. And there I showed you that some other scientists tried to get more information about the income distribution in Germany, and they looked at the data of public finance, and especially the tax data, and there they deduced also data for the very rich people, so the 0.01% richest people in Germany, and that these so-called super rich persons, if you take this data within the official data, then the Gini coefficient really, or the Lorentz curve, moved really to the right, and that we could say that the Gini coefficient of roughly 0.3 for Germany increases really with around 0.05 points up to 0.35, and then of course we are moving just in the neighborhood of course UK. So always be careful and look at the quality of your data. Yeah, we have here already a time series, and right now we want to go in a deeper analysis of time series, and for this we start with a very important topic, and this is the question how to make the price adjustment. If you look at economic data, then quite often you have a measure which is a composite of prices, quantities, or quite often you have prices within your data, and very often you want to have information about the so-called real variables, because you want in your analysis to get rid of only the price effect. And for this, we want to talk about how to create price indices and what are the problems of these price indices, and what does it mean if you calculate these aggregates. So if we look at some market, or if you look in general, if you take on the macroeconomic perspective, the private consumption in an economy, then of course in general our prices change. And if some prices change and some other prices stay constant, then you quite often talk about a price level. But then is the question, if only some prices have changed, yeah, how did this price level change? So what kind of aggregation should you use in order to get a price level of a market, or even to get a price level of the total economy? And the problems you have there, this I will show you with a little example. And for this, we just start here. Let's say we have a three goods economy: cinema, books, and jeans. And during time, we have here a price change of going to cinema from 11 to 8, book just increasing from 10 to 18, and the jeans is also decreasing in prices from 33 to 29. And during time, we also changed our consumption of cinema, book, and jeans here from 4 to 8, 10 to 4, and we are increasing the jeans from 2 to 3. So, well, what we at first can do is just calculating the price change on average. We have 3 books, so we just take the arithmetic mean, and after that we could maybe interpret this as the price level. Or what we also can do is that we just calculate total consumption in the years 2015 and 2016. And this we will do. And of course, we will do it again within Excel. So for this, we just copy our numbers. So, and average price in 2015. How do I do this? Just adding up 11, 10, and 33 and dividing by 3. So equals plus 10 plus divided by 3, and then I can just copy my formula and I obtain the average price for 2016. So how do I obtain total consumption? What do I have to do? I have three goods. I have the prices and the quantities. And your task is to calculate total consumption. In the meantime, I save my file. So this was a task. Calculate total consumption. Anybody to give me a hint? You're still there? Or not? No, not add up quantity. Total consumption. If you think of what you are doing, so you are which amount of money you are spending in. Yes, great. Thank you. Oops. So let's do it. 11 times 4 plus 10 times 10 plus 33 times 2. And this we can also copy. And here you see this is also always 8 times 8, 18 times 4, 29 times 3. Well, and so then we could interpret here we have average prices, and we could calculate the increase of the average prices, the three prices divided by 3. This divided by this minus 1 would be the rate of increase, and the rate of the increase of total consumption would be 223 over 10. So in this case, we would have an increase of 1.9%. Is this really the change in price level, or here, if we take just the increase of total consumption, should be this the price level change? And I think I have done it here for you. So should be this really this change in price level? Well, there we have really to make a question mark, because here we do not really have a weighting. So, and if we look at the data, then the price level or the price of jeans is much higher than the price of cinema and the price of books. So in this case, we do not weight the different goods, and therefore, of course, the more expensive a good, the more drives this good some kind of a price, an average price, which we calculate like this. Therefore, the more expensive a good, the more drives this good. The, and I call it now pure average price. And this is, I think, not the thing what we want to have. That if you take a really expensive good, then more or less this determines your price level. And we want, yeah, something. What we need is how to weight these prices. So, well, if we take total consumption, we have this change of 6.2%, and actually we see that they differ quite a lot. And in this case, we can say, well, we have some kind of weighting because we multiply the prices with the quantities. But what we are doing here is that we are changing from one year to another year the weights. And this we have also to question. If we always change the weights of our prices, then we are, of course, fluctuating every year in our weighting. So in this case, the weights of the prices are always changing from year to year. And this, of course, we have also to question, because in general we want to have the same yeah weights, or that we have something, if we are compare these things, that we want to have these things, some things, if we compare this over time, that these weights stay more or less constant. And I think, yes, in my macro course, we already talked about this, that more or less every 5 years, we fix our weights due to some general, coming from a general basket of consumption, so that we really have these weights fixed. But also we can think of that we, yeah, look in these years once from the actual perspective, or the other way around, we look from history into the future. And what we want to start now is that we just ask ourselves, what are the costs of this basket, cinema, books, and jeans, if we take the basket of 2015? This means we take the quantities of 2015 and ask, what is the price of these quantities in prices of today, in prices of 2016. And this then we compare with the costs of this basket in history in the year of 2015. So this we also want to do in Excel. So this, let's put in another column. So basket 2015 in prices of 2016. So what we have to do then is just calculate these quantities for, and now not multiplying with the 11 from 2015, but with the price of 2016. So what we are doing then is that we take the weights of, take the quantities of 2015 as constant, multiplying once with 2015 and the other time with 2016. So the calculation with 2015 we had already. This was the 210 here. And now we want to know, what is the price of these three quantities in the year 2016. So let's do it. 11, no, 8 times 4 plus 18 times 10 plus 29 times 2. This is then our 270, and let's take here the basket of 2015 in prices of 2015, and this we had already calculated. This was the 210. So let me see this also. There. And a bit longer. So let me see what we are doing. So, and now we can calculate, of course, the change due to these two numbers. Again, this we had already, so we can take this, and in this case, we would have a change, so to speak, in price level of 28.6%. And this I also had already done for you. So in this case, the weights of the prices stay constant, and we use as weights the quantities of the year 2015. And since we are now not changing the weights, then in general this could be interpreted as a change of price level. Then this can be interpreted as a change in price level. So, well, then is a question, well, if we take this as an interpretation of change in price level, what else could we do? What else could we use as weights? Do you have an idea? So now we choose the year 2015 as weights. And then we looked forward. What are the costs of this basket of 2015 in 2016? How could we also construct a measure where we take the weights as constant? Well, in general, we can just use the year 2016 and the quantities of 2016 as constant, and then we will look backwards. And at first, well, there is no reason to do it that way or to do it the other way. But before we want to do it, we will just generally define what we have done here, where we took as um, where we took the basket in the history as the reference point, and we just calculate all the prices with the weights of the historic years. And this kind of calculation has invented an econometrician called Laspire, I think in the beginning of the 20th century. Well, and that this is just a weighting we can see in the following way. So what we are doing here is we calculate what we have done. X I know 0. This we can interpret are the quantities of yesterday, and we multiply this times the prices of today. So we take some reference year, t equals 0, and then we take the quantities we have consumed in t equals 0, and we multiply these quantities then with the development of prices during time. Or in general, we take t equals 0 as the reference year, and we weight all prices in the future with the quantities in t equals 0. Well, and in order to create a price index, then of course we always normalize these numbers. And how do we normalize this? Well, we just divide these weighted baskets with the weights x0. We divide this just with the total consumption in the year 0. So this is the normalization, because this is our reference here. So normalization with the expenditure in the reference year t equals 0. Well, and then we just can manipulate this formula here a little bit. Since yeah, we expand this here just by P0 over P0. So Pi0 over Pi0 is of course just only 1, and therefore we multiply our formula just with 1. And yeah, what is the nice little thing if we do this? Well, here we have the relative price change of every single good. So this PIT over PTI is more or less, or not more or less, is just the change of every single good. So this is the relative price change. Of every single good. And what do we have here? Here we see that we only have our zeros. So all this is calculated in the reference year. So what do we find here then is just the expenditure of good I in year 0 divided by the total expenditure in t is 0. So this is expenditure of good I in t equals 0 divided by the total expenditure. In t equals 0. Well, and this is then, so to speak, a natural weighting. So this is then the weight for the relative price change of every single good. So the Laspire index is therefore a weighted, and this is in difference what we have done in the beginning, where we just added up here our three prices, 11 plus 10 plus 33 over 3. Now we are weighting these three relative price changes with the weight equal to the proportion of the consumption of this good in the reference year. T is 0 relative to the total consumption. And actually, this is the way how we in general calculate our consumer prices. And so this is our general interpretation of inflation. So in general, the consumer price index is calculated in that way. Well, and here I show you just the so-called harmonized consumer price index, and this harmonization is made for the total Eurozone, or of course also the EU, the European Union. And here what we see is what are the actual wages which we have right now. In general, we see here the dramatically high inflation rate due to this, and then we see that our sub-indices, they differ very much in their single increase. And here especially we see housing, electricity and gas, that they have risen just in September 2022 by this really huge amount of more than 20%. And I think I also can click on here, so you can just also have a look at this. Hopefully this functions. Yep. And there you have here quite nice general dashboard where you can click in. You can also look at the data within the Eurozone, and in general you get many information about the consumer price index, how it is calculated in Europe, and then you can more deeply understand what we mean by inflation. And this is of course right now one of the main problems we have in our economy. Okay, but then we want to move on, and of course with the Lespaya price index, we take the situation in history as constant and weight with this historic proportions all our relative price levels. And of course we can do it the other way around, that we take the situation today as constant and we look back. and this we want to do here. So we ask ourselves, what is the basket of today? What are the costs of the basket of today? So in our little example, in the year 2016 with prices in 2015. And this then we compare with the costs of the actual basket with prices of today. Move back to our calculations. So what we need now is the basket of, let's put it here, 2016 and prices of 2015. So what we have to do then, of course, basket 2016, so 8 times 11, 4 times 10, and 3 times 33 equals 8 times 11 plus 4 times 10, oops, this was too fast, plus 3 times 33. So we have 227, and then of course the basket of today in prices of today. So basket of 2016 in prices of 2016, and this of course we have already done here. So equals 223. Again, we want to calculate the relative difference, and then maybe quite surprising, but if you look at my example, I took really an extreme example because prices here of cinema are decreasing and the quantities are increasing, and here the quantities are highly decreasing, and here the quantities are more or less staying constant. So I created here a quite extreme example, but I created this also for the reason that we see here, because at first we think of, well, it doesn't matter, or we cannot really distinguish what is better, to take the weights of 2015 or if to take the weights of 2016. But if we change this in this extreme example, then we would obtain here a high increase in price level and here quite surprisingly a decrease in price level. So, and also this I calculated here for you, but I think I should put it also here. Let's take this. We have it later on. And also this one. Put here relative change. And so let's do it like this. So again, what happens here always. Oops. And in this case, here our relative change. This. Okay, then we have this surprising decrease in price level. In this case, we use the actual quantities as constant and compared to this case here, and therefore the quantities of 2016 are the weights for the price development. And also this approach can be interpreted as a price level index. And of course, also this kind of approach is used in econometrics. Especially we use this, and this we will show later on, when we look at the so-called GDP deflator, the whole price index. Because when we talk about inflation, then we look only at private consumption. There we use in general the concept of Laspaya, where we took as weights the situation in history, and if we use the concept which we have here, that we take the actual situation as our reference point. This concept we use when we calculate the whole price index of an economy, but in detail we come to this later on. Let's at first also have a deeper look how this kind of approach is constructed and what kind of average process we obtain then, because this, as we will see, is a bit different as in the concept of Laspaya. And this is called the so-called Target index. also an economist 100 years ago. And what we see here now is, well, we take constructing this index, the basket of today. So this is expenditure of today divided by the quantities of today now multiplied with the prices of yesterday. So this is then quantities of today multiplied with prices in quotation marks of yesterday. So here we look back in time, and with the Laspire index we looked forward in time. Well, again, what we can do is that we move just in this formula and, so to speak, nice little one, because TTI over TTI is of course again 1, and then we can manipulate this formula by inverting it. So if we put the upper side down here, so if we just switch it and we divide it by 1, then we see here that this part moves down here. And in a second I showed you why we just take this exposition of our formula, because if you look at this part here, then this is constructed in the same way as in the Laspire index. Because here in the Laspire index we had the proportion of good I in time t in time 0 divided by the total expenditure in time 0. What we have now here is the expenditure of good I in time t. Remember, in this case we are looking from the actual situation. So this is the expenditure of good I in time t. Now t is our reference here, and this is total expenditure in time t. So what we have here all together in this, oh, let's take red again. is again the proportion of expenditure of good I relative to total expenditure in time t. And so to speak, we again can interpret this as the weight for, again, the relative price development. So this is again the relative price development. But you have also to be careful. If you look at this, we have here the 0 above and we have here the index t, so it's also just the inverse which we had compared to our Laspire index, where we had here the t and here the 0. Well, and if I write it, let's take a new slide. Different averages, because this construction then at a first look seems quite funny, but if we remember our introductory courses in statistics, let's take two numbers, x1 and x2, and we want to calculate the average. Then, of course, we took the arithmetic mean, and this was just x1 plus x2 times 1/2. We had the geometric mean, how did we calculate the geometric mean of x1 and x2? Maybe you can help me. Any idea? Geometric mean of two numbers? Arithmetic mean was the sum of two numbers divided by 1/2. The geometric mean, you always need this if you want to calculate the average of growth rates or interest rates, in general yields of some investments. Well, then you calculate x1 times x2, so the product, and we have to take the square root. Well, and then we have a third one, and this is the so-called harmonic mean. And what we do then is that we calculate 1 over 1 over x1 plus 1 over x2, and here we need a 2. And this, at a first look, seems quite surprising, but what we have here in general is just that we write x1 up to the exponent -1 plus x2 up to the exponent -1, and this also up to the exponent -1 times 1 over 2 to the exponent -1. So we just see here the dependence between the arithmetic and the harmonic mean. It's more or less totally the same, only we just put here -1 on all parameters, on all variables. And also, if we look at the dependence between arithmetic mean and the geometric mean, then we just interchange the operators and everything else stays the same. Well, and all these kind of averages, this can then, of course, moved to weighted averages. And then we just move in that we say x1 will be g1 times x1. And this we have only to interchange. Oops. So just put in here for x1, g1, x1, and here also, and so on. And then we can see that this harmonic mean is nothing else than what we constructed here with our Parsha index. Because here, this is just the inverse of our price relative prices. Let's put this in green. Inverse of relative prices, and here we have totally the inverse, and we are weighting this with our proportion of the expenditure in times t, and therefore the Parsha index is nothing else than the weighted harmonic mean of relative prices. And as I already mentioned, this Parsha index is quite often used as a concept of GDP deflator. So, and what is then the difference between these two kinds of possibilities to measure price level? And you see the outcome of these two concepts could be quite different. Well, in general, we have the problem if we want to calculate a price level effect, that of course the quantities of consumption depend obviously on the prices itself. So we have always some kind of substitution effect, and in my example I also had this substitution effect, I think, yeah, here. So this one, price moves down, then quantity moves up. This is the natural movement which you have when prices are changing. And also we can say over time, if we always take one specific reference here, then during time some goods are vanishing and we have the invention of new goods. Or think also about the quality of goods over time. So you can think of a handy and you think, what could you do with your handy 10 years ago? Then this was, of course, quite different to the things you can do with a handy today. So are these two goods 10 years before and today, are these really the same goods? This you can, of course, also question. Well, in general, we can say that the price level of the partial index will be smaller than the price level of the Laspire index if we have that the relative quantities negatively correlated to the relative price development. Well, and this is, of course, the general assumption which we make. This is the general assumption since we have in general a demand for goods which is decreasing in prices. So this is just your demand curve, which you have seen so often in your studies. So, and if we take this, then in general we can say that due to this especially substitution effect, that the Laspire index in general would more or less overestimate the general price level increase, and the partial index would underestimate the price level increase. And of course, then, as it is always the case, you have to look at your framework, at your setup, what you want to analyze, and then you have to choose the right concept which you need to answer your question. And therefore also we cannot say that the Laspire index or the partial index is the right one. You always have to choose the your concept due to the question what you want to analyze. Okay, that's for today, and we will go on with the price adjustment the next week. Thank you very much. Then there was also the question what we choose for our exam, and most of you voted for the digital version, so we will write a so-called E-Hausarbeit in this lecture. Yeah, then thank you very much for today.